All available experts, please report to room A9.
Hello guys, Exeter here. Today I'm going to go over the module Increasing Indices. The basic gist of this module is we're going to be solving these equations and choosing the roots of the polynomial. There are multiple ways you can do this. You can either guess the coefficients, guess the roots, and then do polynomial division to find the rest of them, or my preferred method is subbing numbers into the equation. So let's define x as a number. And this is our equation. So the equation is easy, to be honest. I could solve it generally. We just had to find a number that when the two numbers added together, you get -1, and multiply is going to give -12. So our probability is -4 is 4, possibly. Basically, in other words, this equals sum A plus B, and this equals sum A times B. So we could have x minus 4, x plus 3. Multiplying this out, we get x squared minus 4x plus 3x minus 12. Combining these two terms, we get our minus x that we want. So this is what it will be factored.
Emergency cleared. All personnel, please return to your stations.
So now say this equal to 0 is slightly easier because we now know that either x minus 4 has to equal 0, or x plus 3 has to equal 0, meaning our roots are 4 and minus 3. So let's press them. And we move on to the next one. See, we could try and factor this as well. Personally, I prefer subbing it into the equation. Granted, this might not be the intended method for this module, but it is a method that works. So let's... One thing I can tell you though is, if there is a constant on the end, 0 will never be one of the roots. Okay, so let's try 1. We get 0, so let's click that one. Let's try minus 1. We also get 0. Let's try 2. We get minus 6, so that's not a root. 3 gives us minus 8. 4 also gives us 0. And that was all the roots for that one. The quadratic will always have 2 roots. The cubic 3 and then the quartic 4. So let's now put this in to it. So x to the 4th plus 4x to the 3rd plus 3x to the 2nd minus 4x minus 4. So we see 4 is not the answer because it gives us 540. Again, we know 0 can't be it because we have a constant on the end. Let's go for 1. Is one root. Let's try minus 1. Is another root. We're not done yet. There can be repeated roots, so if we want, it can solve before you press 4. 2 is not a root. Minus 2 is a root. We have that module. Let's do another one. This one, if you know a bit of shortcutting with maths, you know that this is a difference of 2 squares, namely x plus 2 and x minus 2 is the factorization of this difference of 2 squares. So this is a squared number, this is a squared number, and since we're taking the difference between them, we can multiply these out and show x squared plus the 2x from one bracket minus 2x from the other bracket, because this minus 2 replies with this x, and this plus 2 replies with this x, then minus the squared 4, these two cancel out, giving us the x squared minus 4, being our two roots of 2 and minus 2. Okay, next one. X to the third plus 4x squared minus 3x minus 18. So minus 2 is not one of them because that's minus 4. 0 is not one of them because we have a constant. 1 is not. Minus 1 is not. 2 is. 3 is not. 4 is not. Minus 2 is not. Minus 3 is. And since I think we've checked all the rest of them, one of these two was repeated. Yes. Final equation. X to the fourth minus 3x cubed minus 4x squared plus 12x. Since we don't have a constant on the end here, we can immediately press 0 because the 0 would have cancelled out the entire constant term. Because if we divide through by, since x equals 0, that term would have been just a bracket which was x plus 0 or just x. So our new polynomial would be x to the third minus 3x squared minus 4x plus 12. And you see the constant term here gets obliterated when we multiply by a singular x, because there's no constant to keep an x-less term. So that's why if there's no constant term, you can press 0 immediately. So 1 is not another root, neither is negative 1. 2 is another root. We still need more. Negative 2 is also 1. And this one actually had 4 different roots, so the last one was 3. And that's our module. So, have you know a method of doing increasing indices? There are many other methods of doing increasing indices, but this is the one I find simplest to do. And I'll see you guys in the next tutorial.